All right, so we're going to do a lot of the same things we did yesterday, is looking at the graph and finding the midline and the amplitude and the period and stuff like that. But we're also going to go a step further and use those things to write the equation of the function. And so just some reminders that the midline is actually corresponding to a vertical translation, and hopefully that makes sense to you. So the vertical translation is something added on the outside that's going to affect the midline of the graph. It's going to shift it up and down. All right, and then the amplitude is going to correlate to a vertical dilation. So that is the bigger the amplitude, the taller the graph is. The smaller the amplitude, the shorter the graph is. And then the period correlates with a horizontal dilation. So the longer the period, it's like a stretch, and then a shorter period is a compression. All right, and so those three things correlate to A, which is what is in front of the sine and cosine. And that's going to be kind of the amplitude. Let's add a little absolute value on the A in those parentheses. The amplitude is always positive. The way it's worded there, it looks like A is automatically the amplitude, and that is not true. So let's just make a little note. Bless you. All right, and then what do you think happens on the graph if that A is negative? So let's say you, in front of your sign, you have like -2. What do you think the negative does? A negative on the outside.
Flips it.
It does flip it. Good. It's a reflection over the x-axis. All right. And then the D part here that is added or subtracted at the end is going to represent the midline, the vertical translation. And then B, what's multiplied by your variable on the inside, is going to be a horizontal dilation. And that comes into play with the period. And so the period is always going to be 2 pi divided by whatever that B is. All right, now I forgot to do something. Let's go back up and draw a little sine graph, just a parent function sine and a little parent function cosine graph. So what is the period of just how long does it take for one cycle of sine in the parent function?
2 pi.
Yes, thank you. So 2 pi is going to be the end of one period, and then we'll put a little midpoint at pi and a couple more little midpoints at pi over 2 and 3 pi over 2. All right, so what is the sign of 0? Try to picture the unit circle in your head.
0.
Yes. What is Ethan giving you all the answers? Okay, what is the sign of pi over 2?
1.
Yes. Sin of pi?
0 again.
Yes. 3 pi over 2?
-1.
And 2 pi?
0.
Good. All right, so that is going to be the shape of the sine graph. So he was getting that out of his head from the unit circle. So just picturing where 0 was on the unit circle and choosing the y coordinate. And then for pi over 2, picturing where that was and choosing the y coordinate. All right, so let's do that same thing for cosine. So the period is the same. It's going to be pi over 2. for the parent function. All right, and then we're going to do the same thing. We're going to picture where these angles are on the unit circle, and then to do the cosine, we're going to give the x coordinate there. So what do you guys think about the cosine of 0?
1.
Yes. Pi over 2 would be 0, -1, 0, 1. So that's the shape of the cosine function. It looks like a Texas Longhorn. So I want you guys to picture, like, when you think of sine, you just picture that shape, that little swoopy shape. When you picture cosine in your mind, just picture the Texas Longhorn. That's important. So today we're going to take these different graphs and we're going to find the equations when they've been stretched and when they've been shifted, but they will have the same basic shape. Okay, so let's do that for example 1. So example 1, they have identified all the things that we identified yesterday, the midline, the amplitude, and the period. Now we're going to use that to find A, B, and D, for this equation. All right, so for me, the easiest one to do is midline, so I usually start with D. So if the midline is 3, that means D is 3. All right, most of the time, A just straight corresponds with the amplitude. This is one of those times. So if this one doesn't have a shift left or right, so if I'm starting at 0, this is the regular sine shape. So the amplitude is going to be a +6. If, for some reason, starting at 0, you had an upside down sign, then that would just make the A be a negative. All right, sorry. For B, we do have to do a little bit of work. So it told us here on number 3 that the period is equal to 2 pi over B. And it is the absolute value of it, because the period also has to be positive value, just like the amplitude. So it tells us here that the period in this situation is pi. So I'm just going to put that in for P, and then I'm going to solve it for B. What would you guys do to solve it for B? Multiply by B. I don't know why I wrote it that way. It should probably be pi B. And then divide by pi. Now, one thing you can do if your period is not a fraction, you can just switch these. If your period is a fraction, when you switch it, it makes it weird. You have a fraction inside of a fraction, and that's weird, but that's something that you can do. So anyway, B is going to be 2. So this would be 2, this would be 6, and this would be 3. All right, let's look at the next one. We're going to do kind of the same thing. So we haven't talked about shifting horizontally yet. So if there isn't any shifts horizontally, and I start at 0, what does this look like? A sine or a cosine? This is a sine. So in the end, we're going to write an equation for f of theta. So we're going to have to figure out something for A, something for B, and something for D. All right, so D is definitely the midline, which is 3. A is going to be positive something because it does look like the correct right side up sine graph. So what do you guys think A is? 3. That distance between the middle and the max. Okay, and then for the period, what is the period here? Pi. So we've already done this once, but the period should be equal to 2 pi over b. So b is going to be 2 pi over pi, or just 2 again. All right, and then all I need to do is go back to that purple equation and fill in A, B, and D. All right, any questions? Now on this next one, I'm going to do more than what they asked for because I just think it might come up again. What do you guys think D is on this one? What's the midline?
Say D, -1.
Yes. Oh, you didn't understand me. Yeah. D is -1. Okay, I'm going to ask this differently than before. What would you say the amplitude is? Yeah. Why do you think I didn't say what A is? Is it very good? It is negative. So if I'm starting at 0, that is an upside down sign. So this one also has that reflection. So A would technically be -2. Amplitude, always positive. All right, what about the period? Yep. So this one I'm pretty sure you could have done yesterday. The question is, which is true? What do y'all think? A. They could have made it tricky and had -2 as the answer for the amplitude. Don't ever pick a negative amplitude as the answer choice. It's definitely going to be wrong. Okay, and then for example 4, you guys have done a lot of these where you just give the midline, the period, and the amplitude, but now we're going to actually pick the equation. All right, and so we have this trigonometric function k, and it does have a maximum point at 0, 6. So if none of these have any kind of shifting left or right, this one I feel like is a little on the easier side. It's possible some of these would be sine and some of these would be cosine. Now, one thing to keep in mind is that cosine with no horizontal shift has a max at 0. So if you're trying to decide between sine and cosine here, because that cosine has a max at 0, this has a max at 0, it's going to be cosine. All right, so we're going to do the same thing we did before when we're trying to find the D and the midline and the amplitude and the period. So do you all want me to draw it, or you just want it, you done?
Draw it.
You want to draw it? Okay. So I know at 0, 6, I have a max, and then I know at pi over 2, -4, I have a min. And so it's something like that. Less wobbly though. All right, so what is D, or what is the midline going to be?
2, 1.
Yes. So mathematically, all you have to do is find the average or add those two together and divide by 2. Now, last class I realized after I did that all of these have the same D value. So that's probably something we could have left out, but it's okay. It might be more challenging on your actual assignment. But it's also good to find that so we can find A. How do we find A once we figure out
You
that?
have to do the other side, right?
Not yet. So I know the midline is 1. A is going to be the distance between that midline and the maximum. So what would it be? 5. So what can I mark out for my answer choices? Yeah, A and B aren't happening. So what is it going to come down to? The deciding factor. The B, the period. And so what I have here from 0 to pi over 2 is half a period, right? Where would the whole period end up? Up high. Now, I probably should change this, but I think every one of these, the period has been pi, but we'll do some more in just a second. So B, don't forget that the period is equal to 2 pi over B. So B is 2 again, and that's going to be choice D. Okay, so we're going to go through some multiple choice questions that are pretty common. I think the 2 ways they're going to ask you about graphs, or 2 of the ways, is give you the equation and you pick the graph, or give you the graph and you pick the equation. Going from graph to equation, I think, is a lot more challenging, but let's look at this one. So we have this graph, or this function, f of x, and we want to find which graph it matches with. So what is the midline of this function? -1. So they all have a midline of -1 except A. So A is done. The rest of these have the right midline. Also have an amplitude of 3, I'm pretty sure, yeah. And they all look like the sine curve. So it's going to come down to the period again. Okay, so when you have the equation and you want to find the period, you do 2 pi divided by B. What is B in this case? So 2 pi divided by 2 is our favorite number. Oh wait, hold on. 2 pi divided by 2 is pi, our favorite number. All right, which one of these has a period of pi? Yeah. So this is 1 period of sine. It's completed at pi. All right, what questions do you guys have so far? Because it's about to get a little more challenging, because now we're also going to start shifting these things left and right. Are y'all okay? All right, you're about to know. So a shift left and right is called a phase shift. I will still sometimes call it a horizontal translation, but with sine and cosine curves, sinusoidal curves, is called a phase shift. And just like before, when we were shifting left and right, you shift by the opposite value, or the opposite amount, units. So a positive inside is going to shift it to the left, a negative inside is going to shift it to the right. Okay, so here we go. We have this graph, and we want to know which one of these things it is. So we cannot, whenever there's a shift left and right, we cannot make a determine if it's sine or cosine from 0. We have to look at where the new starting point is. Okay, so does this one have a phase shift? A phase shift will happen inside the parentheses. No. So this one is still going to start at x equals 0. And it should look like cosine. So starting at x equals 0, it should look like the Texas Longhorns. So if I start at 0, when t is 0, or x is 0, sorry, does it look like that? No. So that's not it. So we go to the next one. Does this one have a phase shift?
Yes.
Yes. This one also has a reflection. All right. So since this one is shifted pi to the right, we're actually going to start at x equals pi. It's a new starting point. We don't start at 0 anymore. And since this one has a reflection on the x-axis, it is going to kind of look like Texas Longhorns, but I hope there's no Texas fans in here because it has to be like horns down, Texas Longhorns. Apparently that's super offensive. I don't know why, but it is. Okay, so let's go to pi. Does it look like that?
No.
It actually does. Oh, no, it doesn't. So then we're going to say no. All right, you ready?
Yeah.
Where are we going to start out on C? It's tricky. Yes, maybe it's not tricky. Because this one actually shifts to the left. Now we don't have a negative pi over 2 on our graph. Does that mean we are just hopeless? It doesn't. We can do this. So we're going to approximate this much in the negative direction. So we're going to say it's about right there. And we're just going to continue the pattern. Like you can picture what that would do in your head. Now that's not perfect, but it's enough. Okay, now don't forget to check to see what type of function it is. So this was sine. So starting at negative pi over 2, it should look like the sine graph. The right side up sine graph. So does it?
Oh, sorry.
No. All right, so hopefully this last one works. All right, where are we going to start out on this one? 3 pi over 2. And what does it need to look like? Upside down sign, good. All right, here's 3 pi over 2. Do we have the upside down sign? I think so, yeah. So that is it. If it wasn't, we were going to be in trouble. I know it's extremely time consuming. Unless one of the first ones you check is the answer. These take off forever. Okay, let's do one more of those and then we'll do the most important problem on this page, or in this notes. It's gonna go faster because you guys know what you're doing now. So do double check that they all have the right midline of 1. They all have the right A value, they do. And the B is the same. So sometimes it's possible you might be able to narrow down choices because something doesn't match up right. But Brian Passwater has written these questions that you have to use the phase shift to get the right answer, which is good because that's what we're learning right now. Okay, so where do we start at on A? Yes. And then it should be a regular Texas Longhorn cosine graph at pi over 4. Now pi over 4 is not labeled, but you guys are smart. You know pi over 4 is going to be halfway between those. Do we have the right shape? No. Okay. And then for b, I'm going to start at x equals pi. And then this is a positive cosine, so again, we're looking for that cosine shape. And we don't have it. This time, I want to start at pi over 4 again, and I'm looking for the sine shape. Do we have it? There it is. All right. What questions do you guys have so far? We're almost done. It's a long lesson. Okay, so I know you guys have seen this guy. Like maybe the first day of school we did something using it, but we've been doing these a lot. This one, the stuff we've been doing, has been done for us. We're going to do the one thing we haven't done for this FRQ, and it's find the values of A, B, C, and D. Okay? And so I know the Y values. I'm going to go ahead and fill them in. It might not be necessary for you to do that, but you will have done this already by the time you were doing the finding A, B, C, and D stuff. So we know the Y's, we know the heights, and we know the times. Okay, so we're going to find A, B, and D, just like we've been doing. Nothing's different. C, it gets a little tricky, but it's super doable. So I like to start with D. What do you guys think D is? Yeah. So it's going to be whatever you put here. That is always going to be D. A is always going to be the common distance between those. So what do y'all think? Yep, good. Okay, and then to find B, remember that the period is equal to 2 pi over B. And the period is going to be the distance between maximums, I guess. The distance between our maximums, what is that distance? 12. Okay, and then in this case, we can just switch B and 12. And B is going to be pi over 6. All right, so those are things we've done several times today. Now these questions could say sine here, or they could say cosine there. We're going to practice a whole lot of sines so you get comfortable with that, and then we'll do some cosines. It's just one slightly different thing on this step right now. We're going to focus on sines for a second. So to figure out C, I'm just going to use this part of the equation that is in parentheses. So we're going to use B and then in parentheses T plus C. I'm going to ask you a few questions. So the first question is, when does the parent function y equals sine of t have a max? Like what time or what angle? I'm going to scroll, after you guys get that written down, I'm going to scroll back. Or you guys can flip over on the front if you want to. So we did a parent function at the very beginning of class. So what angle gives sine a maximum?
Pi over.
Thank you. So what you want to do is take that little section we just had and set it equal to that angle or time when the parent function would have that maximum. Okay, and then the other question is, when does this graph have a max? There's two answers here. I typically use the first one. There are many, many correct answers to this equation, so it's fine. There's multiple correct answers, but I typically use the first max. So what do you guys think? 2, right? The y is 16, but the time that it has, that maximum is 2. All right, so this 2 is going to go there. Do we know what b is? We just found it. We're going to put that 2 in for t, and that leaves us with c as the only variable we don't know and the only variable we need to find. So at this point, we're going to solve this for c. What would you guys do first to solve it for c? Oops, sorry. Say it again? You could distribute. I think that's going to make it harder, though. Divide. So we can divide by pi over 6. How do you actually do that mathematically if you don't have a calculator? And you won't have one. Multiply by the reciprocal. So we end up with 2 plus c. Those pi's cancel out. 6 divided by 2 is 3. So c is 1. Magic. All right, what questions do you guys have? It's a lot of super important things.